We've been asked to find the exact value of the tangent of 17 pi twelfths. So I want to use sum and difference formulas in this video, and that's my primary goal in doing this. In particular here, I want to start by using the addition formula for tangent. The tangent of alpha plus beta is equal to the tangent of alpha plus the tangent of beta over 1 minus the tangent of alpha times the tangent of beta. So the first thing I need to do is think about how to express this angle 17 pi twelfths as the sum of two different angles. And so I'm asked to find an exact value, so I'm thinking about using angles that are on my unit circle that I know a lot about. And so multiples of pi sixths are very nice, multiples of pi thirds are very nice, and multiples of pi fourths are very nice. With a denominator of 12, I think I can probably do this in some way. So let's see, 17 pi over 12 is equal to, and I want two fractions added together. Right now I'm going to think about them as having a denominator of 12, right? Thinking about adding fractions with a common denominator. And if I was just to think about the 45-degree angle at pi fourths, right, that would be 3 pi twelfths. Well, to get up to 17 pi twelfths, I would need 14 more. So that seems to work. And then when I reduce those fractions, I get 7 pi 6 plus 1 pi fourths. And those are two angles that I know a lot about from my unit circle. So those are the two I'm going to choose to use. Now I wanted to think through this problem in radians, but maybe, just maybe, some of you watching the video are thinking you'd have an easier time in degrees. So let's just think about 17 pi over 12 converted to degrees. That'd be 255 degrees. And all of a sudden in degrees, I don't think it's nearly as interesting to think about that as two unit circle angles, 210 degrees plus 45 degrees, which is 7 pi 6 plus pi over 4. Now there are any number of other angles in degrees to choose or in radians. These are just the two I chose to look at. All right, well, I'm ready to apply my sum formula for tangent. So tangent of 17 pi twelfths, well, that's 7 pi over 6 plus pi over 4 on the inside of that tangent. And now I can use my addition formula. So it's tangent of the first angle, 7 pi over 6, plus tangent of the second angle, pi over 4. And then on the bottom, 1 minus tangent of that first angle, 7 pi over 6, times the tangent of the second angle, pi fourths. Well, we know the tangent of pi fourths is 1, so that is 1, so that's going to be an easy part. 7 pi 6 is an angle down in quadrant number 3. And nicely, tangent's positive in quadrant number 3. And looking at where that is on a unit circle, I know that's going to be the square root of 3 over 3. And so I can just fill in those values. And I get root 3 over 3 plus 1, and then 1 minus root 3 over 3. And I can multiply top and bottom by 3 to clear the equation of fractions, and I get root 3 plus 3 over 3 minus root 3. And there's an exact value for the tangent of 17 pi over 12. Root 3 plus 3 over 3 minus root 3. And assuredly, we could rationalize that denominator and simplify our fraction, but I'm going to leave it just like that. But kind of oddly, I'm not done with this problem yet, because I really just wanted to use a bunch of addition and subtraction formulas in this video. And this is the way I would do this problem if I just happened to meet it in the wild. But I want to now go through and do this problem again, but using the addition and subtraction formulas for sine and cosine. And better said, I'm just using addition formulas here. So the addition formula for sine and the addition formula for cosine. Because I know that every time I have a tangent, it's really a sine over a cosine. And we already know two angles to use, 7 pi over 6 plus pi fourths. And so I should be able to get to the same value, the same exact value, using the addition formulas for sine and cosine. So the addition formula for sine, the sine of alpha plus beta, is sine alpha cosine beta plus cosine alpha sine beta. And then cosine's addition formula is cosine alpha cosine beta minus sine alpha sine beta. So I just get to go through now and plug in everything where it goes. So on top, we have sine of the first angle, 7 pi over 6, times cosine of the second angle, pi over 4, plus the cosine of 7 pi over 6, times the sine of 7 pi over, the sine of pi fourths. And on the bottom, I have that cosine pattern. So the cosine of 7 pi over 6 times the cosine of pi over 4 minus the sine of the first angle, 7 pi over 6, times the sine of the second angle, pi fourths. Well, we've already identified 7 pi over 6 as being down in the third quadrant where cosine and sine are both negative. The sine of 7 pi over 6 would be minus 1/2. The cosine of 1 pi fourths is root 2 over 2. I'm working on the top here. Plus the cosine of 7 pi over 6 is minus root 3 over 2. And the sine of pi fourths positive root 2 over 2. On the bottom, I go through and do the same thing. And I have the cosine of 7 pi over 6 is minus root 3 over 2. Cosine of pi fourths, still root 2 over 2. Got the subtraction sign from my addition formula for cosine. The sine of 7 pi over 6 is minus 1/2. And then finally, the sine of pi fourths, root 2 over 2. So if I just look at everything on top, I have minus the square root of 2, minus root 6 all over 4, divide by minus root 6 plus root 2 all over 4. The over 4's definitely cancel. And so I'm looking at minus root 2 minus root 6 divided by minus root 6 plus the square root of 2. And I'm done. I found my exact solution again. But I know what you're thinking. It doesn't look like it did the last time I found the exact solution of this angle. And so I need to convince us that these are really the same. And so the first thing I'm going to observe here is that every single number here is divisible by the square root of 2. So I'll multiply top and bottom by 1 over root 2. And let's see, I would get minus 1 minus root 3 all over minus root 3 plus 1. And if I multiply top and bottom by a negative 1, well, let's see. That would give me a 1 plus root 3 over root 3 minus 1. Well, I see a whole lot of 3's there, but it's still not what I got last time. Well, I can fix that by multiplying the top and the bottom by the square root of 3. I'll get root 3 plus 3 on top and 3 minus root 3 on the bottom. And now I've verified that those two numbers we got were very mysteriously the same number. Well, I think if I was ever asked to find this exact value, I'd just use my formula for tangent, but now we know we could also use the formulas for sine and cosine.